This is the prep packet video for Unit 4, Chapter 9.5. This is for objective number 3, where we multiply a binomial containing radical expressions by a monomial, which is really a fancy way for saying we're going to distribute. So let me just do a quick thing here. You're used to distributing. You've been doing it for quite some time now. So if I had 5 times x plus 3, I would distribute this monomial to this binomial. And I would get 5x plus 15. You've seen it before. X times x plus y will give me x squared plus xy. So, whoops, we're not doing anything we've never seen before. Let me just erase that. So what we're doing is now we're going to distribute over expressions that contain radicals. So here, 4 times the square root of 5, not too hard. And then here, 4 times the square root of 20. Now, I might think I was done, but maybe I'm not, because are my radicals the same? No. Is this radical a factor of that one? Yes. So let's do some experimenting and see if we can take this apart. This is the same as 4 times the square root of 5 times the square root of 4, because 4 times 5 makes 20. So that gets to come out and be over here. So now I have 4 times the square root of 5 minus 16 times the square root of 5, which gives me negative 11 square root 5. So again, you always want to simplify. It's just like you always want to reduce fractions. You always want to get this as tidy as you can. So let's take a look at this. So the square root of 2, I'm going to do this a different way for you. First I'm going to distribute. So the square root of 2 times the square root of 10 gives me the square root of 20. The square root of 2 times the square root of 15 gives me the square root of 30. Now let's see if we can do any reducing. So 20 is the same as the square root of 4 times the square root of 5. And this is the same as the square root of 5 times the square root of 6. So this would be 2 root 5 plus the square root of 6 root 5. Okay, see that common factor coming up? There's that and that. So now I get to say the common factor is that, so it's the square root of 5 times what's left, 2 and root 6. Again, we started, this was kind of messy, and this is a little bit easier to understand and see. Let's see what's going on over here. So first I'm going to distribute, so there's that. And remember, the square root of x times the square root of x is x. Not x squared, x. And then the square root here, and that'll give us the square root of 32xy. Because remember, because of the multiplication rule, or the product rule, you get to just put it all over that. Any square roots hiding in here? Well, not with the variables, but this would be 16 times 2, right? So this will come out as a 4. So we'll have x plus 4 times the square root of 2xy. Again, we're just trying to simplify it. It's like peeling an onion. See these. So here, first I'll distribute. So I'll have 4 times the square root of 3 times 6 is 18, all under the radical, plus 2. The square root of 6 times the square root of 6 is 6. So let's see if I can do any simplifying here. This is the same as 9 times 2. I can do something with a 9. So he'll come out. So I'll have 4 times the square root of 9 is 3, times the square root of what's left behind is 2, plus 2 times 6 is 12. So 12 times the square root of 2 plus 12 equals 12 times the square root of 2 plus 1. Don't you dare leave those undone. I want to get it down to those basic factors. So here, let's see what's going on here. So there's that. So that's 3 times 6 is 18, the square root of 18, plus 3 times 5 is 15, the square root of 15. That's the same as 2 times 9, and that's the same as 3 times 5. So no square roots hiding. There's one. So he's going to come out. And we're going to just leave 15 alone since it's the product of two prime numbers. And there's not much I can do in terms of factoring that down. As long as you get things down to primes, you know you're in pretty good shape. As long as you get things down to where they aren't squares, you're in good shape. Let's take a look at this one. So can I combine these? Not right now, but I'm going to use some background knowledge and think, well, 7 is a factor of 63. So let's work on what's inside the parentheses first, as Aunt Sally would suggest, PEMDAS. So 63 is the same as 9 times 7, right? So I can factor that down to, I'll take the square root of 9 out, which that gives me 3 root 7 plus root 7. So how many root 7s have I got? I have 4 of them. And then I'm going to multiply all that by 3, so I end up with 12 root 7. And again, I used my background knowledge because I saw that 7 and that 63 and I got suspicious. So let's see what's going on over here. Let's see. Inside the parentheses, I have m and n. Not much I can do there. But I can do something with the square root of 18, because that's 9 times 2, right? So I'm going to rewrite this as the square root of m times 3m square root m, plus that 3 is going to come out, leaving behind 2n. Now I'm going to distribute. So the square root of m times that would be 3 times square root of m times the square root of m is just m. And then here I'll use my product rule, and I'll have 3 times the square root of 2mn. Now let's take a look at this. Do I have any common factors? Why, yes I do. I have a 3 and a 3. I'll pull that out and I'll end up with 3 times m plus the square root of 2mn. One thing I want you to think about too when we're factoring is that eventually you'll be multiplying and foiling these, so it's a lot easier to get it down to that basic factor that you're used to working with. So for more practice, which is a good idea, there's a couple of U-tries on page 556, and again, be sure and include your work with your prep packet. And that's it for now. Thanks a lot.